Hello, this is a video for Data Structures 249, Module 4. As you'll see, this runs for the next 2 weeks, and I want to make sure that we get you set up on how things are going. So you've hopefully by now done the first part of the reading to understand how linked lists work. Now, again, if you've been working with C++ versus Python, this is probably a good read for you. So C++ students are used to arrays, and so you have the idea of a structure that is fixed. You can easily swap things in an array, as we saw with the sorting code, but you can't really resize them or add things to the beginning or the end. But with Python, with lists, you're used to being able to add things wherever you want. If you reference the Python list, in any of your previous Python textbooks, it's pretty straightforward how it works. So what you kind of see here is with linked lists with Python, you may go, well, what's the big deal? Because this behavior is something you're kind of familiar with. But versus C++ arrays, you haven't had this functionality. As I kind of mentioned here, if you have read about vectors, which you may or may not have seen, they work sort of like lists do. And it's not just that linked lists are a way to implement lists, they're a way to implement data structure in general. Getting used to this idea of having these nodes connected to each other is going to be quite useful, because we're going to, and I'll give you just a quick example of what a linked list looks like, right? Please, thank you very much. I'm going to close all of these and go to my, there we go, click away from this. So just to make a random linked list, let's do it of size 7. That sounds good. Now what do we have here when we look at a linked list, right? Well, we have the node itself. A node consists of two things. It consists of the data inside the node and then the pointer to the next node, which we call next. Now here on this viz algo, they use head and tail as being a node themselves, and that's certainly one way you can do it. There's other ways you could do this. So we'll say here we have a node at the head of the list, and depending on your implementation, so when we look at singly list data structures in Python versus C++, they're implemented differently, but the behavior is the same. The important thing here is that we have this piece of code. Let's again go to the location so I can show you in both languages what it looks like. The fundamental structure is the node. Now, if you are used to one language versus the other, it's okay that you can write in just one language, but you should learn to be able to read both languages. So when I look at this and see, well, a node here contains an integer, and it contains a pointer, which is a reference to the next node, versus in Python, I see here, well, I have my data is the data that I pass in, which is just a variable, and this next is none versus null pointer here. In both cases, what we're dealing with, now let me show you an example here. There's a piece of PDF that I'm going to upload for you in just a minute. You may want to read some information about Ask TeacherBot. I put that up there for fun. Why would you care about this information? Why would you be interested in this material? Now, this is an excerpt from a book called SICP, Structure and Interpretation of Computer Programs. This is written in Lisp, L-I-S-P, which is not a language you're probably familiar with. But the structure will make sense to you. So when you see box and pointer notation, this is the kind of notation that we show you here in the book, right? So here, consider this being one node where the data points to the number 1, and here I have next. Now, of course, this is pointing to a number, so some of these show you can do kind of arbitrarily complex structures with these, but we're going to be doing lists where you just have one piece of data and then it points to the next node, and all nodes are of the same shape. You may find this reading interesting, you may not. It's sort of an interesting background for how we deal with pairs. Now, this is the one really that you want to look at, okay? So this is what we would think of as a linked list in the traditional sense. I have the head, which is a node, and the node contains the data 1, and then next contains a reference to the next node, and so forth and so forth. And the last one has, depending on language, either null pointer or none. In either case, this doesn't point anywhere, and it's represented like this. So this is the structure we're going to be building. In the initial tutorial, what we sort of do is we start with an empty list, and then we build a list that just contains this item, and then we add this item in front of it, so now we have 2 in the list, and then we add another one and another one. So the idea is we're appending things, we're prepending, we're adding things to the beginning of the list, because that's an easy thing to do. We already have the head, so I just change the head and I leave all the other structures the same. It's like a chain of beads. I just add a new bead to the beginning, and now I have a longer chain. All right. So that's where we're starting. Now, you're going to be doing the reading, and again, I would focus on 4A for now. This is not important for the tutorials. And what you're going to want to do is implement 4.6. Okay, so for M4T1, you just go to the relevant section. Now notice here there's lots of code, and they even will give you all the code. But what we really care about right now, if I can scroll down here, sorry, I'm pushing too many buttons. You'll see that you have multiple files here. So I have the main, this is the using the list, and this is the implementation of the list. Now what you would do is you would take this code, put it into a code block project, or put it into a Visual Studio Code, or put it into a REPL.it, and you would use these separate files. So we'd still start with main as we always do, but this now includes a file. Now you're going to see we're going to use includes more in both languages as we go forward, so just keep that in mind. But this code will not work without both of these files. Now I want to show you the Python version, and it's the same situation. So you're going to see a lot of parallels. That's why I really think it's important that even if you don't write both languages, you learn to at least sight read both of them, get a general idea. Like you can see in both cases, hey, I'm making a list and I'm adding nodes to it. And here I have, in this case, two different files. We put node separate from linked list. You wouldn't have to do this, it's just for convenience. And again, whether you're running Anaconda or Idle or REPL.it, you would need all three of these files in your project, and then you would run this code. So that's just, for tutorial 1, it's really just run the code. But what I would encourage you to do is to make some changes, because I want you to understand how this works. Now, for now, what I really care about is learning how to add things to a list, either to append, which is add at the end, or prepend, which is to add at the beginning. All right. The next tutorial is doubly linked list, but here now what I'm saying is instead of just using the code directly, I want you to take your main.cpp or main.py. Well, first, do this, right? Do the one they provide, and then make another list. And I say here, so it could be spoon, stapler, whatever you want, right? Just some strings. So we're showing the idea that it doesn't have to be a list of ints. It could be a list of strings. It could be a list of students. It could be a list of video game objects. I mean, it could be anything. We'll just use strings for now. And by now, you should have an idea, well, what would I do to make a list with 5 objects? Print the list, which, how do you print the list, right? You iterate through each item in the list, traversing the list, and print the items. Add item to the end, add item to the beginning, and print it again, and now you'll have 7. Okay, that's got you started for the first tutorials. As we get into the lab and to the assignments, what we're talking about now is the idea, if I were to go back to that SICP reading, of, oh wow, I could have anything could be my data. So we're not going to do it like this, but the idea would be, well, what this might be is it might point to a record. Now, what's a record? Well, a record is just an object or a struct. So instead of having the number 1, this could point to student number 1, and then this student itself would contain like a name, address, phone number, a grade, and so forth. We're not doing student, that's kind of complicated. What we're doing in the tutorial, the lab, and then the homework would be to create an item. So what I'm thinking about is a storefront, right? So I could make an item, which would be an object in your chosen language, and it has a name and a value. So it has a name and a price. So spoon, $5 or whatever. And then again, you're going to do these behaviors. So that's going to get you through the first 3 assignments. Again, if you have any questions, remember, you can always contact me on the Thursday Help Lab. And I'm happy to take emails, but hopefully this will give you a little bit of idea of what's going on here. And I would say it's not a bad idea to watch one of these videos to get a visualization. In the face-to-face class, I've kind of done a lot of writing on the whiteboard, and I think you'll find this is pretty useful to have some sort of visual explanation. Thanks a lot, and I'll see you in the next video.